increasing, decreasing, and constant functions. So let's start with an increasing function. No, the remote's not working. We say a function is increasing on an interval if, right, when you take 2 points on the interval and you compare the y values, so if you have x1 and x2, f of x2 is higher than f of x1, right? Or f of x2 is greater than f of x1. That's how we say it's increasing, right? So if you keep taking, more and more points, right? Like as you go further and further, for each x value, the y values are going up. That's an increasing function. That's how we define it mathematically. Now, does it take much for you to look at this and say it's an increasing function? Not at all. If you look at it left to right, yeah, it's increasing. A decreasing function is when on an interval, for every x1 and x2, f of x2 is less than f of x1, right? So it's literally decreasing. We say a function is constant on an interval when for two values, x1 and x2, their y values are the same. That's how we know it's constant. Okay? Now, let's talk. Okay, so here's what I need you guys to understand, and this is like a subtle thing that people miss sometimes. Increasing and decreasing is defined over an interval. So something is never increasing at a specific point. It's only increasing from point A to B. It's only increasing from 1 to 3, not at x equals 1. Okay, that's going to be important when we identify the regions where something is increasing and decreasing. That's number one. Number two, when we talk about increasing and decreasing, we talk about the x values over which something is increasing or decreasing. So not the y values. So here, it says consider the following graph to determine the intervals on which the function is increasing, decreasing, or constant. So when you say intervals, we are talking about the x values. Okay. So when we start off always from the right, always from the left, correct? This function is increasing to this point to here, right? So it's increasing. Now only look at the x values, please. It's increasing from -infinity all the way to -3, right? So I say it's increasing from -infinity. Before I write it down, let's just go through the whole thing. So this is increasing, and then it starts to decrease until about this point, 2. And then it's increasing, then it's constant, right? It's increasing until this point, and then it's constant. So the way we do it is we are going to write down all of the regions where it's increasing, decreasing, and constant. So we say it's increasing first from -infinity to -3. Now, remember I said at a specific point, it's never increasing or decreasing? For that reason, I'm going to keep that open, okay? And then, union, where else is it increasing? From 2 to 6. Okay, always keep these open, right? Cool. Okay, decreasing, where is it decreasing? -3 to 2. Where is it constant? 6 to infinity. Okay, so this is also consistent with the way we do it in calculus. So that's how I want us to do it here. Okay, moving on. Constant is 6 to infinity. Never closed, always open. Because we don't know. Because remember what I said, at x equals 6, you can't say it's constant because it always has to be compared to another variable. Compared to another value. Okay, So, increasing, decreasing, constant. So, okay, the first one, what do you guys think? Where is it increasing? Where is it decreasing? Where is it constant? Okay, I have an increasing the entire time. Does everybody agree with that?
No.
No? What do you guys think? It's constant in the middle. Where? Here?
It's just zero.
It's constant? Okay, so let's see if it's constant. Constant means what? If you take two x values, the y values must be the same. What is the function for this? Y equals x cubed. So are there any two values that when you plug them in, the y values stay the same? No. So if you had, let's say, 0, it's 0. Now you have 0.1, then it's 0.1. If you have 0.2, then it's a little bit higher, right? So it is increasing all the time. Okay, good. So now you see how the graph and the function, right, can be used together to figure this out. Okay, what about this next one? Where is it increasing and where is it decreasing? From 2 to infinity, and it decreases negative infinity to 2. Okay, decreases, increases, x values only, never y values. Because 4 is a y value. Yeah. Okay, here. Increasing from where to where? Okay. And then it starts to increase here at 3 again, right? So from 3 to infinity. And then it's constant from 0 to 3. And it's not decreasing anywhere. Okay. Right.
Why is it?
So it's the x values, never the y values. Always the x values. Okay. Here. Later. Yeah. Okay. So it's increasing, and then it starts to decrease. And then it starts to increase again. Okay? So this is increasing from negative infinity to what first? Negative 1. Okay? Here. Okay. So another way, right? Okay, so from negative infinity to 1, and then it's decreasing, and then it starts to increase again from x equals 1 to infinity. The most common mistake here is people in the beginning just confuse the x and the y, and they put in the y values. Don't let this happen to you, okay? Decrease from negative 1 to 1. Okay, before we move on to the next page, take a look at what happens here. This function was increasing, then it changed to decreasing. At the point where it switched from increasing to decreasing, what do we have? We have a peak, or we call that in math a maximum. So the point where the function switched between increasing to decreasing, we have a maximum. And the point where the function switched from decreasing to increasing, we have a minimum. Okay? Now, before I get your question, let me give you a thinking question. Don't call this out, okay? Is there ever a situation where something changes from increasing to decreasing and there is not a maximum at that point? Okay, so let's just think. Let's not call it out yet. Is there ever a situation where something changes from increasing to decreasing and there is not a maximum at that point, is the question. Okay, now, who says yes, there is a situation like that? Who says no, there is not a situation like that? The no's are right. In fact, that's like a thing. That's how maximum and minimum are defined in math. That's how we define it in math, right? It's got its own definition, and that is it. Yes.
So,
Yeah, you involve.
even if it's going for like infinity, or there's like a higher point, it's still called a maximum.
Okay, I haven't gotten there yet. But yes, it is. Yes, it is. Okay, so here we go. Yes, it is. Okay, so now, a maximum, right? So whenever a graph changes from increasing to decreasing, that's a maximum. Okay? We also call that a relative maximum. So a relative maximum is the greatest point over some interval. Over this interval, that is the maximum point. So we call it a relative maximum. Okay? Now, this is also a relative maximum. If I were to, okay, so in math, we rarely look at the entire graph on its, like, at the same time. Most of the time, we only look at a local value. So if I give you a region here, okay, this is the maximum. If I give you a region here, this is the maximum. Now, so they are each called relative maximum. When I zoom out and I'm looking at the entire graph together, like all together, the very highest point that the graph reaches, that is called an absolute maximum. Okay? So, in here, these are both considered maxima. This is the absolute maximum. All others are relative maxima. Okay? Okay. Now, same with minima. You have a minimum here. You have a minimum here. This is the absolute. Oh no. This is the absolute minimum. Okay? And then this is a relative minimum. Okay, now, let's do this next example. Okay. Estimate and classify the local and absolute extrema. Minimum and maximum together have an umbrella term as extrema, right? So an extremum can be either a min or a max. Cool? Okay, so when you have this, you have to identify all of the minima and the maxima. Okay, why don't we go for a maximum first? Do you see how this is a maximum? This is a point where the graph increases and then decreases. That's a maximum. Is that the absolute maximum of this graph? Is that the highest point? No, right? So there is a relative max at, okay, and there are two ways of writing this. You can either say 0,3, or you can say there is a relative max at f of 0 equals 3. And I know we cover this in algebra 2, so you know how to do this. This is the function notation. Oh my God, I have so much to say about this. Okay, next, minima. This and this are minima here, right? They equally, share that absolute minimum position. So it's totally cool. You can have that. Absolute minimum are f of -1 equals -1, f of 1 equals -1. These are both absolute minima. Okay? Okay. Yep.
So we wrote relative max since we weren't able to find the absolute max.
Because okay. So there is no absolute max here because these increase to infinity. So there is not even an absolute max. Yeah. So it's a relative max. Okay. Oh yes, that's a thing.
Why isn't that why isn't that the absolute?
The absolute maximum is by definition the highest y value the graph ever attains. Okay. Okay. So for the next ones, estimate and classify extrema. So what do you guys think about the first one? Absolute minimum is f of what? F of 3 equals -4. Okay. For the next one, you guys are comfortable using a calculator? Let's plug it into the calculator for the next one. Yep.
Why can't you say absolute like maximum is like near infinity or is that
No,
not
because it has to be a point. And infinity can never be a point because it's not a defined value. Yeah. Okay, so in our calculators, we're gonna put in, don't you guys love math? I'm so excited. This is one of my favorite things to teach. Okay, so here we go. All right, let's do it. X to the power of 5 minus 2x to the 4 okay. So you should get a graph that looks similar. If you really want it to look identical to mine, you could just adjust the window so they look identical to mine. But regardless, all we're doing this for is to figure out the minima and the maxima. So how do you guys find minima and maxima? Because there is more than one way. How would we? Okay, so there are two ways. One is menu, analyze graph, maximum, and then I'm gonna find the leftmost point, which is that one. And you guys know how to grab them and move them somewhere so you can see it better? Okay. Please go ahead and plug this in and make sure you're getting several decimal places here, because sometimes I'm going to ask you to round to 2, sometimes 3 decimal places. Are you all getting enough decimal places? Okay. Do you guys know how to increase? Huh? Well, do you know how to increase it to more than 4? You can hover and press the plus sign. You can hover on top of the text, press the plus button, and it increases it as much as you want. And then you can press the minus to decrease the number again. It is so flippin' cool. I know. So, what is that, by the way? Is that a relative or an absolute minimum?
Oh, I did a max.
So, a maximum, sorry.
Relative.
It's a relative max. So we have a relative max. And it'll be f of -0. I'm going to go to 3 decimal places. 958 is equal to 2.020. I'm going to 3 decimal places because on AP Calc it's always 3 decimal places. I'm also going to 3 decimal places because often for students it feels kind of weird to write something like this, like f of such a crazy decimal. But you know what? It's totally cool. It's just a matter of getting used to it. So when I press escape here, oh, yep.
Is there another maximum?
Yes, there is. We're nowhere near done yet. We're also not going to do all of it. But another way, was it Sammy or Jordan who said the trace? Another way to find minimum or maximum is when you trace. So you can do analyze, graph, no, I'm sorry, menu trace, graph trace. And then the downside here is you have to go slow enough that you don't miss it, right? So if you keep traversing the curve, this is what we call hopping along the curve, you will get to a point where it labels maximum, and then you have that. But be careful, if you don't get that confirmation that it's a maximum, you can't use it, right? Just because it seems close enough. So you have another relative max and that's f of 0.659 equal to 0.478. Okay. I'm not actually going to do the rest because I know you guys know how to find the rest, okay? But is there an absolute minimum? Is there an absolute maximum? Okay. I'm going to talk about one other thing, which is super, super important. Terminology. When you are asked, okay, for the first one, the parabola, when you are asked for the location of the maximum or the minimum, that's the x value. You say x equals -3. The location is x equals -3. When you are asked for minimum value, what is the minimum value? That's the y, and you say y equals -4. You know mathematicians, they are nothing if not efficient, right? And every word is calculated, get it? Every word is calculated to mean something specific, okay? All right, let's do the next one. Actually, I don't think, do we need to plug in the next one? You guys are okay with finding minimum and maximum? I don't think we need to waste time plugging in another one into the graph, right? I think we're good. We can move on to the word problem. Okay. Question?
No, just we weren't looking for the minimum.
We were, but I think we're okay with it, so I'm just gonna move on. Okay. Optimization. This is a big deal in math. Okay? Guys, put away your cell phones. Okay? Optimization is a huge part of math. Basically, it is where we try to see how we can minimize or maximize a quantity. Okay? All right, so take a look at this one. Advertisements for a new car claim that a tank of gas will take the driver and 3 passengers about 360 miles. Okay, that's a distance, right? After researching on the internet, you find the function for miles per tank of gas for the car is this. X is the speed of the car in miles per hour. And F is, what was F? F is the distance per tank of gas. So if you have a 12 tank car, how much can you drive? 280 miles, 340 miles, whatever. Okay, what speed optimizes the distance the car can travel on a tank of gas? So explain to me, what is it that we're looking for? The maximum of what? The maximum that you can, okay, what speed will give you the maximum distance? Okay, so what speed will give you maximum distance?
Will give you highest y value.
Right, so what speed gives max distance? Okay, let's go ahead and plug that in. Okay, tab, I'm going to delete the first one, and in its place, we're going to put in this one. Go ahead, please, everybody, plug this into your calculators. Plus, okay, and you should get basically nothing on your calculator if you have my screen, right? So part of the reason why we're doing this problem is because we also want to get a window that is optimal for this. Okay, what does the x-axis represent here? What quantity? I want a word. The speed. Okay, x value is the speed, so it can't be negative. What's the y value? Maximum what? What's the y value? Distance. That also can't be negative. Okay, so this is f of x, and this is x. X stands for speed, and okay, so let's go to menu, window zoom, window settings, please. X is the speed of a regular car, right? So the lowest it can go is 0. What's the highest it could go, you think? Huh? No. We're going to drive very safe speeds. We're not going to go that high. We're not going to go that high. You're scaring me. Let's go to 100 because I'm a mommy and I don't want anybody thinking they can go that high. Okay. All right? Okay. But is there a car what car goes to 240? Yes. We're not driving those. We're not driving those. We're driving like a Toyota Corolla, okay? That's what we're driving, okay? A good Toyota Corolla, okay. A RAV4 goes how much? I have a RAV4. Oh my God.
RAV4s go fast.
Try that.
Like an old 2000 something on the Odyssey, and it could go maximum of like 1.
We also have an Odyssey, but we've never. Okay. 80. Now you're talking. That's what car I'm getting my kids. Yes. So Distance 0. This is the farthest it can travel on a tank of gas, and here it's about 360. I'm gonna overshoot, and I'm just gonna go 400. Okay. Oh, look.
Why'd you go for?
Because it, like in the problem, it said that they were going 360. So I'm like, let me just go past that a little bit.
Why is it?
Correct. Why is the distance?
So what was that? I said why minimum maximum?
So 0 to 100, 0 to 400. Okay, maybe I'll go to 120. I mean, 100 is good enough, but here, okay? You can see it curving better. Do you see how it's getting to a maximum somewhere in the middle over there? This is what we want. So we're going to go to menu, analyze graph, maximum, here. Oh. There we go, yeah. So 70, comma, 362.5. So the maximum is 70, 362.5. Okay, so take a look. We got to go back. We had identified that the x value represents the speed. So this is the speed. This is the max distance, right? Because we know there is city mileage, there is highway mileage, right? And if you're driving too fast, now you're on the other side of the problem where you're not going to drive that much distance because now you're overusing the resources of the car, right? So now we actually have to write this in a coherent English sentence using correct grammar and syntax. Okay, let's do this. So basically, the optimum speed, okay, is 70 miles an hour. Okay, so the car will travel a maximum distance of 362.5 miles at the speed of 70 miles an hour. Okay? So, what can you keep out of this and what can you not keep out of this? You cannot keep out of this maximum distance 362.5 miles. That's got to be in there. Speed of 70 miles an hour. Other than that, car will travel, that you can fudge with. Okay? But you have to have quantity, value, unit. Okay, very quickly, yes.
How did you get it so it's 362.5
As opposed to
mine's just 363.
Probably in your settings.
hover on top of the number, hover on top of the 363, press the plus button. Yeah.
Oh,
Do we always have to change our Windows settings?
Yes, to model the problem, to fit the problem. And each problem will have a different situation, right? If you're talking about grades, you're not gonna go to, yeah.
It's not working on my calculator. I put in the equation and I changed the settings and it's not.
It's like a 15 on a scale of 1 to 10, okay? If you ask me, is this gonna be on the next test? Yes, okay? Okay, let's do this. Yep. Average rate of change. What's another word for rate of change? You learn it. It's one word, one syllable, huh? Slope is rate of change. Slope is rate of change. Did you say slope?
Yeah, like
Oh.
a while ago.
Okay. Okay, so slope is very easy to find when we have a linear function, okay? When you don't have a linear function, it's not that easy to find. But if you want the average rate of change between 2 points, what you can do is draw a line that connects the 2 points, okay? This red line crosses this graph at 2 points, just like on a circle. We call that a secant line. How many times does raise your hand, how many times does a tangent line cross a circle? Raise your hand. Okay. Once. Same, a tangent line crosses a circle once. It hits a circle once. Okay? A tangent line hits the circle once. A secant twice. Same thing with the function. This is the secant line through the function and so on. Okay. To find the average rate of change, you basically have to find the slope of the secant line. That's it. Now, back in the day, you used to write slope as y2 minus y1 over x2 minus x1, right? Okay, no longer. Now if you have x2 and x1, the slope is going to be f of x2 minus f of x1. Okay? So, you have an interval, -3 to 1, -3 to -1. You want to find the average rate of change of this function on that interval. So, this is x1, this is x2. So the slope of the secant line is f of x2 minus f of x1 over x2 minus x1. Okay, this is f of -1 minus f of -3 over -1 plus 3. Now take a look. This first thing I wrote down is extra. This thing, whoops. This thing here, that should be somewhere in your problem. If you want to start off, you want to make that the first step, totally cool, but you can't not write that. I can't stress that enough, okay? Now, the second one, the highlighted one. Now, how am I going to get, raise your hands please, how am I going to get f of -1? Somebody on this side of the room, somebody on this side of the room, raise your hand. Okay, yep. We're right, but we're not going to do that. What else are we going to do? Yeah. Plug it into the function. Okay? And you get 0 minus -24. If you plug -1 in here, I already did it. Like, you get 0 minus -24 all over 2.
You're plugging it into the -2x squared plus 4.
Correct. So that gives you a 12. That's the rate of change, average rate of change. Okay? Question? Oral, question?
Yeah, where'd you get 0 and -1?
Okay, that's what I was just saying. You plug these numbers, -1 and -3, into this function. Okay. Sometimes you'll be given the graph, okay? So the slope of the secant line is between those 2 points, f of 4 minus f of 2 over 4 minus 2. F of 4, -2. F of 2, 2. All over 2, that's so many 2's, but it's still -2. Okay? So that is the average rate of change. And that's the end of section 4.